Think that you wake up one morning, look in the mirror, and there it is, your very first gray hair. You start thinking, wait, am I really getting old already? Or is this because of stress? We've all heard that stress can make your hair turn gray. But is that actually true? In this videocast, we're diving deep into the science behind it. How stress messes with your body, your hair follicles, and even your cells. So let's find out, can stress really steal your color?
Okay, let's talk about something I think almost everyone wonders about at some point. You know that moment. You spot that first, really unexpected gray hair.
Oh, yeah.
And maybe it's right after some super stressful period at work or, something intense happens. And you immediately think, that's it. This stress is literally turning my hair gray.
It feels true, doesn't it?
It really does. But is it actually scientifically true? Or is that just, a convenient story we tell ourselves, an old wives' tale?
That's the big question, yeah. And honestly, for a long time, the science is kind of wishy-washy on it. But we've dug into some really interesting recent studies, including a big one in Nature.
Ah, okay.
And these are starting to move us past just stories. So our mission today is really to unpack the biology here. Like, how could stress, especially that sudden, sharp stress, mess with how our hair gets its color?
Right. So the plan is, first, let's quickly cover how hair gets color in the first place, the basic mechanics.
The building block.
Exactly. Then we'll dive into the specific ways stress might throw a wrench in the works and maybe why the results could actually be permanent, which is kind of alarming.
It is. It suggests a difference between just normal aging and, something more like a biological accident triggered by stress. But yeah, let's start with the normal process. What should be happening?
Okay, baseline.
True.
So the sources often use this analogy, like each hair is a tiny little painting being created. What are the cells doing the painting?
So the main players are called melanocytes. These are specialized cells right there in the hair follicle at the root. Their job is basically to produce melanin, which is the pigment.
That's the actual color.
That's the color. If the melanocytes are working, you get pigment. If they stop or they're gone, the hair grows out without pigment, gray or white. So they're the artists mixing the paint.
Okay, artists need supplies, right? They can't just paint forever without backup.
Exactly right. And that's where the melanocyte stem cells come in. These are super important. Think of them as the artist's main supply store, or maybe the blueprints for making new artists.
Oh, okay.
They're undifferentiated stem cells, and their job is to create fresh melanocytes when the old ones wear out. Your hair keeps its color over time because these stem cells keep that supply chain going.
So the graying that happens naturally as we get older, that's just the supply store slowly running low on stock over, decades.
Precisely. It's a slow, gradual decline in those stem cells. Fewer blueprints mean fewer new artists over time. That's the normal, age-related graying process. That's the default.
Got it. Okay, now let's connect this to stress. That explosive idea that stress could dramatically speed things up. What happens when the body goes into that high alert pressure mode? What's the trigger?
This is where the research, especially that Nature study, gets really specific. It points to the body's emergency response system, the sympathetic nervous system, or SNS.
The fight or flight system.
That's the one. The system that instantly kicks your body into high gear for survival. Think immediate danger.
And the researchers actually pinpointed a specific chemical signal involved, one that talks directly to the hair follicle.
They did, yeah. They focused on norepinephrine. Now, norepinephrine is a really key neurotransmitter, and it gets released in massive amounts when that fight or flight system lights up.
Yeah.
It's basically the chemical shouting, "Emergency! Everybody mobilize! Now!"
Wow. And they didn't just theorize this, right? They tested it. What happened when they, artificially mimicked that stress signal in the lab animals, injecting the norepinephrine?
Yeah, this was the really striking part. When they exposed the hair follicles to high levels of norepinephrine, those melanocyte stem cells, the vital blueprints, the reserve supply, they got a signal.
What kind of signal?
A signal to basically turn into mature pigment cells, the melanocytes, all at once. And crucially, they were forced to move out of their protective spot in the follicle, or differentiate way too early, prematurely.
Whoa. So the body's alarm, trying to save itself, accidentally tells the color stem cells, panic, go full production, now. Yeah. And that just burns through the entire reserve.
That's a great way to put it. It's like the fight or flight response inadvertently triggered a self-destruct sequence for the hair's color potential, instead of a slow, steady supply over years.
Boom, all gone at once.
The entire stock of blueprints gets used up almost instantly. The supply store isn't just damaged, it's like emptied out in one go. A catastrophic depletion event.
That distinction feels really important. Normal aging is slow erosion. This is like a sudden, massive withdrawal.
Exactly. Imagine you have a limited set of tools, right? Normal aging is like using one tool occasionally. This acute stress response is like being forced to throw all your remaining tools onto the fire at once.
Leaving you with nothing for the future.
Nothing. Once those stem cells are pushed out and used up, that specific hair follicle loses its ability to create pigment-producing cells. So the hair that grows next is white or gray.
And the speed of this, it suggests that maybe one really big shock, like a serious illness or a trauma, could actually trigger noticeable graying quite fast.
That's what the mechanism implies, yes.
Yeah.
And that leads us to, well, the really sobering part of the research findings. Permanence. Once those stem cells are gone, depleted in this way, it looks like they're gone for good. The hair follicle's ability to make color seems to be permanently lost. You can't just, calm down later and expect them to reappear.
Okay, that definitely raises the stakes. But we need to pump the brakes a little, right? Introduce some caveats. Because not everyone's experience fits this sudden dramatic shock model.
Absolutely. That's critical. While the biological mechanism they found is compelling and it makes chemical sense, we have to remember these were primarily experiments on mice under very specific controlled acute stress.
Right.
We can't just assume it works exactly the same way with the same intensity in every human under every kind of stress.
Yeah, and I think this is where a lot of people might be thinking, okay, but what about just chronic stress? You know, the constant pressure, the deadlines, raising kids, years of working a tough job. That seems to cause graying too, doesn't it? Surely that slow burn is doing something.
That's a really important point. And this is where we might need to think about different types of stress having different effects. Remember, the #1 driver of graying is still genetics and just plain old age.
Okay.
This specific study identified a very particular mechanism, this rapid stem cell depletion linked to that massive norepinephrine surge from acute sudden stress, the fight-or-flight kind.
So maybe the chronic stuff, the daily grind, contributes, but maybe not through this exact emergency evacuation of stem cells pathway.
That seems plausible, yeah. Chronic stress could definitely accelerate aging and graying, but perhaps through other routes, maybe things like ongoing inflammation or oxidative stress wearing things down generally, or hormonal changes. It might speed up that normal aging decline.
But not necessarily trigger that same catastrophic, immediate wipeout of the stem cell reserve that they saw with the acute stress.
Exactly. It's a different kind of pressure. So maybe think of it like this. Your genes basically set the timeline for graying.
Right.
A massive acute shock might be like hitting a fast-forward button, jumping ahead suddenly on that timeline. Chronic stress might be more like just turning the speed dial up slightly, making the clock tick a bit faster than it otherwise would.
Okay, that distinction makes sense. Genes are the map. Acute stress is a sudden detour. Chronic stress might just be driving a bit faster on the original route.
That's a good way to visualize it. The intensity and the type of stress really seem to matter for triggering this specific, potentially permanent biological effect on the stem cells.
And we also need to remember, stress isn't the only thing outside of normal aging that can cause gray hair, right?
Oh, definitely not.
Yeah.
It's crucial to mention that. Things like nutritional deficiencies. B12 is a common one. Copper, too, certain illnesses, autoimmune conditions. These can absolutely cause or speed up graying, too.
So it's not always stress.
Not always. Stress can be a contributor, sometimes a major one, especially the acute kind, according to this research, but it's rarely the single explanation for every gray hair.
That level of nuance is important, but still, the core idea that our bodies have this kind of almost accidental self-destruct button for hair color triggered by intense stress. That's pretty wild.
It really is. It directly links a powerful emotional and physiological experience, the fight-or-flight response, to a potentially irreversible physical change. The key is understanding why. The body prioritizes immediate survival, and in doing so, it seems it can accidentally sacrifice these non-essential long-term resources like pigment stem cells.
Okay, so let's try to boil it down. If someone listening walks away with just one main takeaway about stress and gray hair, what should it be?
I'd say the short answer is yes, but with conditions. Severe acute stress can contribute to graying your hair. The science suggests a mechanism where the fight-or-flight response rapidly depletes the essential stem cells needed for color, permanently. But this is likely acting as an accelerator on a process that your genetics and age are already controlling. It's not happening in a vacuum.
Right. So if we wanted to give people a sort of mental formula to hold on to.
Okay, maybe think of it like this. Your gray hair, genetics, the biggest piece, plus age, plus your lifestyle, nutrition, illness, etc., plus potentially sometimes severe acute stress. Stress is an add-on factor, not usually the root cause on its own.
And that really simple, maybe explain it to a kid version.
Okay. When your body gets really, really scared or stressed suddenly, it hits the big red panic button. That sends out a chemical storm that accidentally tells the color-making supply cells to basically use up all their tools right away, and then there are no tools left for later. But mostly, when you get gray hair, it depends on your family history.
Perfect. Okay, that brings us almost to the end, but you mentioned something earlier that feels like a really important final thought, connecting this to the bigger picture.
Yeah, I mean, think about the core mechanism here. It's the sympathetic nervous system, the fight-or-flight response, using Norepinephrine. And what it does in this case is rapidly deplete a very specific, finite cellular reserve, these stem cells.
Right. They don't just grow back easily.
Exactly. So if the body is willing to essentially sacrifice something like hair pigment stem cells under that kind of acute alarm, what else? What does this tell us about the potential hidden costs, the long-term damage of constantly triggering that same intense fight-or-flight system?
You're saying it's not just about hair color.
It makes you wonder, doesn't it? What other precious, maybe finite cellular reserves across the body might be getting depleted or damaged when we're in that state of high alert over and over again? It's potentially a much broader biological cost of chronic, intense perceived threat.
That is definitely something to think about. A sobering perspective on stress. So maybe next time you feel that intense wave hitting, it's worth remembering that distinction. It might not just be a feeling. It could be triggering a biological cascade.
A cascade with potentially lasting effects. Consider the difference between a temporary response and actual cellular loss.
Something to mull over. Thanks for breaking that down.
My pleasure.
Gray hair isn't just about aging. Stress can actually trigger real biological changes in your body that affect how your hair grows and keeps its color. But the good news is, once you manage your stress, you can help your body stay healthier longer. So next time you find a gray hair, don't panic. Maybe it's just your body saying, "Hey, I need a break." I'm glad you were here with me in this videocast. Before you go, don't forget to hit that subscribe button and share this video with someone who's been blaming stress for their gray hairs.